And so, yes, thank you all very much for attending this lecture. I am very grateful to be here. I served as a guest researcher in 2019 at DPRI and really found the community here very supportive. And I'm just delighted to be back and have you all attend this lecture. I want to thank Nakano Sensei for helping to organize this, and obviously Dr. Ana Maria Cruz Sensei for hosting me this summer at DPRI, but also all of the faculty, students, and staff at DPRI who I've interacted with and who've been very supportive. So thank you. I will speak to you today about mobilizing a collaborative community for probabilistic hazard information. And this is a research project in process. And so I'll be very eager to hear your feedback, and perhaps it can shape the next steps in this project. Here's an overview of the presentation. I'll tell you a little bit more about myself, but then describe this mobilizing a collaborative community for probabilistic hazard information project, and describe the attempts that we're making to integrate what are called phi visuals, and phi stands for probabilistic hazard information. We're trying to integrate these phi visuals with what are called wireless emergency alert 360 tornado messages, or WEA 360 tornado messages. Now, WEA stands for the Wireless Emergency Alert System, and this is the major national system for mobile alerting in the United States. And 360 stands for the number of characters that are included in a wireless emergency alert message these days. We'll talk about next steps in the project and answer some questions that you may have. And the presentation today has some interactive components, mostly toward the end of the presentation. So I really encourage you to participate. As Ana Maria Cruz Sensei mentioned, one of my books was recently published, Mobile Technology and the Transformation of Public Alert and Warning in 2019. But my research really lies at the intersection of communication and security more broadly. And here are some other books that I have authored or co-edited. My work in public alert and warning specifically relates to my interactions with Dr. Dennis Milletti. Dennis Milletti was a world-renowned disaster sociologist and perhaps the world's foremost public figure on warning research. And I had the good fortune of working with Dr. Milletti from 2009 to 2016. We have had multiple collaborations over those years. And I'm really in his debt for what I know about and how I approach the study of mobile public alert and warning. And as many of you probably know, tragically, we lost Dr. Milletti to complications from COVID-19 this year. But I hope that in some small way, I'm carrying on his legacy and the research that he was such a champion of. As I mentioned, I served in fall of 2019 as a guest researcher for 2 months. Here's an image or a picture of me with Ana Maria Cruz Sensei's students in one of her classes. I had the good fortune of guest teaching. It was a fantastic experience. And as a result of that, we were able to, that guest researcher time that I visited, we were able to make some research proposals. And so the one I'm going to present to you now was funded by the National Oceanic and Atmospheric Administration and the National Weather Service. But the proposal was developed while I was serving as a guest researcher here at DPRI. Okay, so the first question I have for you is, this area of the United States, represented by the colorful swaths here, it goes by a particular name in meteorological circles. Does anyone know what this area of the United States otherwise is known as? And if you can unmute your microphone and let me know. Does anyone know? Maybe you've never heard. This part of the United States is known as Tornado Alley. And it goes by this name because, as you can see from the colorful swaths here, these represent the annual kilometers of paths of tornadoes within this area. This is another way of looking at this area. These are all the tornadoes from 1950 to 2019 recorded in this area in the United States, actually. And you can see that even though we have tornadoes in every state in the United States, the vast majority occur in this tornado alley, and they are the most frequent and most intense in this area. Tornadoes are the third deadliest type of natural disaster in the United States. They go by the technical name of convective storm. The only other two natural hazards that are more deadly are tropical cyclone, otherwise known as a hurricane, and general flooding. Convective storms are the most common natural disaster in the United States and also the most damaging. Insured losses total at least $10 billion in each year since 2008. So tornadoes are a significant natural disaster and worthy of our attention. Although tornadoes can occur in any month, another question for you: what period do most tornadoes strike? Otherwise, what is known as what is tornado season in the United States, if anyone knows or has a guess?
Can I guess? Since
Please.
Nobody's talking. So I would guess spring, the spring season.
Absolutely right. Congratulations, Anna Maria Sensei. Spring, from March to June, is tornado season in the United States, which we have just passed. Now, in my state of Colorado, which is basically in the middle of the country, we have a significant number of tornadoes, especially in the spring season. The eastern half of the state sees quite a bit of tornado activity, although we'll see tornadoes throughout the state. Question for you: from 1950 to 2006, how many tornadoes do you think Colorado experienced? A, B, or C? If you said B, you're correct. We've had with now including recent years from 2006, probably close to 2,000 tornadoes in the state. So it is a significant location for these tornadoes. In fact, a friend of mine sent me this cell phone video recorded on June 7th, 2021, near Denver, Colorado, of a tornado in progress. And I'm going to play it for you.
Heading east, it is about to cross 66. There is a cool little antique yard right here. There she goes. Look at that. Stunning. Nature at its finest. And again, no sirens, no warning. Had a weather alert warning about 3 minutes after it had been on the ground. Absolutely beautiful.
Okay, so you can hear from her comments, she's not so concerned about her safety, but more admiring the beauty of the tornado. And in fact, it is an elegant kind of tornado that we see in Colorado. It's a certain kind. But the point that I want to emphasize here with this video is she says, no sirens, no warning, got a weather alert warning about 3 minutes after it had been on the ground. And here you can see it roughly translated into Japanese with Google Translate. So what she's talking about there is this warning. It's a mobile alert warning from the wireless emergency alert system. And it says this: National Weather Service, tornado warning in this area until 5:30 p.m. MDT. MDT stands for Mountain Daylight Time. Take shelter now in a basement or in an interior room on the lowest floor of a sturdy building. If you are outdoors, in a mobile home, or in a vehicle, move to the closest substantial shelter and protect yourself from flying debris. Check media. Well, you can see from my friend's video that she absolutely did not move to the closest substantial shelter. In fact, she pulled out her cell phone and began recording the tornado, which is not an uncommon reaction. But the difficulty that the Weather Service faces is actually getting people to take appropriate protective action in these situations in ways that protect themselves and others. This is the wireless emergency alert text roughly translated into Japanese. So she received that warning message on her mobile device based on a system that looks something like this. This is an image from a radar display that the National Weather Service will use to issue alerts. And you can see there's a map here in the background with a radar image of a convective storm, and it's surrounded by this red polygon. Now, ideally, everyone inside the red polygon will receive the mobile alert message, and everyone outside the polygon will not receive it. In this way, the Weather Service is trying to target the warning message to those most at risk and avoid over-alerting people who are not in harm's way. But there's a problem with this type of warning. It's called polygon-based or dichotomous warning. By dichotomous, there's only two warning states. You are either warned or you are not warned. There is no gradient of warning. There is no probability of impact. You are warned or not warned. I'm going to slow down this visual and walk you through one of the challenges that the Weather Service faces using this polygon-based dichotomous warning. Oops, here we go. So you can see here that if you are person A in the polygon, and the tornado is represented by this red dot here, you have considerable time to prepare to take action, to protect yourself. Now, as the tornado moves across the area of the polygon through space and time, it gets closer to participant B here, or recipient B. And you can see in this image, recipient B is outside the polygon and therefore does not receive the dichotomous warning. But as the tornado moves across, you can see the problem. Once the Weather Service issues a new polygon-based dichotomous warning, participant B has almost no time to prepare. They did not receive sufficient lead time in preparing to take action to protect themselves from that tornado. And the Weather Service sees this dichotomous warning as a problem. So what they are doing now is exploring different ways to alert publics to tornadoes. And one of the ways they are exploring is what is called probabilistic hazard information, or PHI. PHI uses a continuously updated probabilistic grid. And you can see this visualized here. As the tornado is predicted to move across the warning area, it generates what we call a PHI swath. And these are the colorful images here moving across the map. And in this warning paradigm, as the PHI plume moves across space and time, those who come into contact with its outer edge will receive the warning message on their mobile device. You can see the intensity of the probabilities increase as you get closer to the center of the convective storm. In this way, a PHI-based warning is allows much more lead time for many people than a dichotomous warning. And importantly for the National Weather Service, it also reduces the number of people who do not need to receive the alert, but are otherwise in the polygon. So you eliminate much of the over-alerting that occurs with the current polygon-based system. Here's another visualization of this PHI paradigm. You can see that the red polygon-based warning here is replaced by a probabilistic grid. And each point on that grid is given a probability of impact based on a complicated model that, frankly, I couldn't explain to you, but that the Weather Service uses in predicting the tornado's trajectory and intensity. Now you can see that, again, that the probabilistic warning extends far beyond the current dichotomous warning area, and it also reduces the area that is over-alerted that's actually not in harm's way. So the question then becomes, should probabilistic warnings be shared with the public? Should these probabilistic warnings replace the dichotomous warnings that my friend received in Colorado and that recipients that we have now throughout the United States? And this is the question we're exploring in this project. It's part of the Collaborative Science, Technology, and Applied Research Program from the National Weather Service and National Oceanic Atmospheric Administration. It's also called the CSTAR program. And again, as I mentioned, we proposed this project while I was serving as a guest researcher in 2019 And the project team includes myself, Dr. Kensuke Takanouchi, Dr. Anna Maria Cruz Naranjo, and Dr. Giuseppe Aliperti. I want to particularly emphasize the contribution of Dr. Kensuke Takanouchi. I was really inspired by his co-authored article, Collaborative Community Weather Information for Meteorological Disasters, a case study of Nakajima School District, Issei. And in this article, he talks about creating a collaborative community with local community members to help construct weather information. This was a very novel idea. We do not do this in the United States. In the United States, weather warning is constructed by experts, not local communities. And so I thought, well, this was a very novel approach, and maybe we could learn something by using this approach in the development of these new fee-based, fee-enhanced warning messages. So we proposed this idea to C-STAR, and they agreed. So here are the program goals, the C-STAR program goals. Just a moment, I need to move my screen around so I can see it. First, we are attempting to strengthen decision-making guidelines for the issuance of fee-enhanced weather warnings as a component of IDSS, I should say. IDSS means impact-based decision support services. And this is the way that the Weather Service supports local communities through emergency management. So we're investigating whether and how tornado probability thresholds, time of arrival thresholds for the tornado, and or forecaster decision points can be mapped to values in the Common Alerting Protocol. The Common Alerting Protocol is an international standard that governs mobile alert and warning internationally, globally. So we're seeing if we can map these two. Second, we want to improve fee-enhanced weather warning effectiveness between NWS and core partners and publics, as well as among publics. We want to, third, pinpoint inclusion criteria and formatting options for fee-enhanced weather warnings within existing mobile public alert and warning platforms, especially the wireless emergency alert system. And finally, we want to ascertain the value of rendering what we call textual impact-based historical context alongside fee content within mobile weather warning messages. And what this means is, what the C-STAR program asked us to do is see whether if we include historical context around disasters, telling people that major tornadoes have happened in their area, does that make a difference to their protective action taking? Does it matter? So we're investigating that as well. Here are the program goals rendered into rough Japanese. So NOAA and NWS actions suggest to us that officials do intend to eventually share these fee products with the public. The reason we know this is we've seen some examples. This is what the interface looks like for meteorologists and forecasters that are working with these fee products. And here you can see an example of a mock television studio where a forecaster is using these fee products and communicating to publics with these fee products in a kind of laboratory setting, seeing how easy it is to work with these products and how audiences might respond. So we believe that they're going to be sharing these products with the public in the future once they've been tested and validated. We have some research working on how audiences respond to these kinds of fee visuals. This is a study by DeMuth et al., and they've looked here at how one's location within a different fee swath will impact their risk perceptions and their responses. You can see by the blue dot here, sometimes the recipient is inside the warning polygon or inside one of the fee swaths, and sometimes they're outside. And then they ask through experimental design what kinds of risk perceptions and responses people have. This is a similar study, but in this case, the fee swath actually moves towards the recipient's location. And you can see here's a digital clock. And the recipient can see how much time to impact the tornado has in their location and in which fee swath they might be found at that time. This is a study by Miron et al. This is a similar study by Shivers-Williams et al., and they looked at different combinations of maps, background radar images, phi plumes, and the colors for phi plumes, one's location, and how you rendered this with labels. And they looked at these different combinations to see what would maximize the outcomes. Now, these experimental findings are quite valuable, but they also have some limitations. For example, the DeMuth et al. Study, it showed that even though there are high means for intended action taking, the experiments actually masked wide variability in people's sense making. And consistent with prior research, some people nearest the tornado hazard would still not take protective action despite clear indications of personal risk. This was a finding that was mirrored in the Moran et al. Study. They found, quote, different participants would take different protective action in different probabilistic cones. And this underscored that, quote, different people had different probabilistic thresholds for taking protective action during the tornado threat. So again, there is not a tight coupling between increased risk perception and action taking. Now, the Shivers-Williams et al. Study found that higher probabilities for tornado impact did prompt more protective action, but there was a complex interplay with message types. Full warning messages were not always the most effective at different probability levels, and the study actually left us with many questions. Now, in a study that recently came out, led by Dr. Kim Klockow-McLean, she was working with meteorologists and forecasters, and she found with her research team that, in her experiments with phi, there was never a satisfactory way to have the warnings automated. Turns out that warnings are a very deeply social process where forecasters are considering a lot about the communities that they're working with, and there is no single way to automate that process. And for us, this idea of warning being a deeply social process is really at the heart of the McPhee project that we have proposed. So these experiments, while valuable, they constrain revelation of actual sense-making processes. Participants are really asked to just say what they would do, but not why they would do that, take that action or not. There's uncertainty regarding the influence of social interaction on phi interpretation and response. And we know from decades of warning research that warning is a social phenomenon. Very, very rarely will people take immediate protective action when receiving a warning. They will instead mill for additional and confirming information from the physical environment and the social environment. It's also difficult to operationalize phi with current technology. We are not yet ready to include warning messages that have phi visuals in them, but we can look at this for the future. And we know from these studies that phi does improve risk perception, but there is uncertainty about whether and how replacing the current dichotomous warning paradigm with a phi-based warning paradigm would actually save more lives or protect more people. So again, our effort here is to integrate these wireless emergency alert messages for tornado with the developing phi images, phi visuals. So the WIA 360 message that I showed you earlier, this is recently deployed, maybe about within the last year or two. Prior to that, from about 2012 to up until about a year or two ago, the messages were only 90 characters. This is what you would have received then. Tornado warning in this area till 6 p.m. EDT, take shelter now, check local media, NWS. So you can see we've had a very strong improvement in the instructional guidance included in these wireless emergency alert messages. And one of the reasons that we've seen this expansion from 90 characters to 360 characters is in part because of research that I helped conduct with the START research team, the mobile device project team. And this was a project that I served as the lead qualitative researcher. Dr. Michelle Wood at Cal State University Fullerton, she served as the lead quantitative researcher. Our PI was Dr. Brooke Liu from the University of Maryland, but Dr. Dennis Milletti was really the heart of this team And we used his research and his wisdom and expertise to guide this project. And so again, we used findings from this project to advocate for the increased character counts that we now see in wireless emergency alert messages. So for the McPhee project that we're currently pursuing, we're going to do something like this. We're going to imagine that participants in our study are here in downtown Denver. And this is an image of the Denver skyline, the city skyline. And in fact, the University of Colorado building that I work in is here in the foreground. My office is on the 3rd floor of that building. And so we're going to bring participants to the ground floor of this building. We have conference rooms there, and we're going to talk to them about these fee-based warning messages. And we're going to imagine that a giant tornado is bearing down on downtown Denver, which actually has happened in the past. So what I've done here is I've integrated a wireless emergency alert 360 message for tornado with a fee visual, and I've derived the fee visual from some of the research that I've shown you earlier. Now I've modified this wireless emergency alert text in a way to account for impact-based historical context and also the fee visual itself. And so the warning message is identical to the one that I read to you earlier, except for the last 2 sentences. In this case, they say, destructive tornadoes have hit Denver before. Again, this is accounting for historical context. And the last sentence reads, probability of tornado strike at your current location, blue dot. Now you can see in the fee visual, the blue dot represents your location at the Denver campus. And you can see the radar image of the convective storm approaching from west to east. And you can see your location within the fee swaths. And if you look at the legend, you will see you are currently in the 80 to 100% probability of a tornado strike at your location. So after I sent this mock message to our contacts in the Weather Service, I received this email back. It said, that is perfect. Whenever fee becomes a reality, I suspect it will look just like that for tornadoes. So this response from the National Weather Service officials that we're working with really gives us confidence that we're on the right track, that these are the kinds of messages that publics might receive in the future. Now, we know from earlier research on mobile alerting that this milling behavior or the social process of warning is kind of a blind spot in mobile alerting research. And in a co-authored study that I participated in, one that was led by Dr. Michelle Wood and Dr. Dennis Maletti, we used emergent norm theory, ENT, to describe how new group norms can emerge in response to a hazard through the process of interacting with others. This is the social process of warning. Quote, as new norms emerge, group members continue to act as individuals, but choose similar behaviors for shared reasons. So this information seeking and confirmation, or milling, it actually can erode the advantage provided by warnings for imminent threats. And this is because if you're searching for additional and confirming information, you're not taking protective action. And in a rapid onset emergency, the time you waste looking for additional and confirming information can be deadly. But ENT, emergent norm theory, predicts that the initial reaction to a fee-enhanced warning message will be to yearn for more information and instruction, just like every other type of warning message. There's nothing magical about mobile alerting. So people will yearn for additional and confirming information. Message recipients may interact with others to form shared understanding. And this interaction with others is really at the heart of this McPhee project that we are pursuing. Our questions for this project include the following. How can or should probability thresholds, time of arrival thresholds, or forecaster decision points be associated with common alert protocol values for fee-enhanced messages? And again, as I mentioned earlier, new research from Dr. Kim Klockow-McLean and her colleagues have suggested that we already have an answer to this question. It can't be done. It can't be automated. It's not reasonable to expect a kind of systematic or unchanging approach to this question. Question 2, can we a 360 tornado message content elicit appropriate protective action from members of the public given their location in different fee swaths? So this question mimics some of the experimental studies that have occurred before, we're asking the same question, but doing it in a more qualitative format. Question 3, how might fee-enhanced WIA 360 tornado messages include impact-based historical context? And what is the effect of including that context? So we want to know, does it make a difference if you tell people that major tornadoes have impacted their area before? Question 4, what fee-enhanced text and visuals should be included in WIA 360 tornado messages? And we've constructed some mock messages to explore that question. Question 5, how can WIA 360 tornado messages use fee visuals to graphically display that an individual is in an at-risk location? And we're following previous studies by using this blue dot format. Question 6, how should WIA 360 tornado messages that include fee content be adapted for collaborative tools such as social media? Again, we want to reduce the delay time in the warning system. So how can we share these messages more quickly? And then based on the CCWI paradigm, this collaborative construction of weather information paradigm, we added 3 more questions. First, how does milling behavior within a group shape fee-enhanced WIA 360 tornado message interpretation and response? Again, we want to focus on this social meaning-making process that occurs within a community. And number 8, how should fee-enhanced WIA 360 tornado messages be adapted to local context? So when we show these messages to the residents of the city and county of Denver, maybe they'll tell us there's certain landmarks or certain things that we should include about the local area that will help people make sense of them. And then finally, how might the CCWI paradigm itself contribute to the development of fee-enhanced weather warning messages within the Weather Service's IDSS framework? In other words, can this CCWI paradigm be used as a kind of model for helping communities interact with Weather Service officials and other local officials in collaboratively constructing these new warning images and warning tools? So the McPhee project, well, it's unfolding in 4 phases. And the first phase is to develop the mock messages and share those with officials and see what the reaction is. And we've shared them with NWS and actually have shared them with some of the researchers who I've mentioned in the presentation today and gathered really great feedback as a result. Phase 2 is to recruit our workshop participants. We're going to have 48 participants and we'll gather at the downtown Denver campus and hold our workshops. Phase 3 is to conduct those workshops, and we'll do that in the fall. And we'll have the participants complete pre and post workshop questionnaires, but really the heart of the workshop is focused on this kind of collaboration, shared meaning making, and discussion. And phase 4 is that after the workshops occur, we'll hold a final kind of meeting or workshop with 2 of the community participants, and then 2 officials from the National Weather Service and 2 officials from the Denver Office of Emergency Management. And we're going to talk about what we learned as a result of the workshops and next steps. So to give you a kind of taste of what we're planning to do in the workshops, I'd like to conduct an experiment with you now. I'm going to ask you when you would take protective action if you were one of our workshop participants. So I hope you can pay close attention and then unmute your microphone and let us know what you think. And actually, this will be the first time that I've ever done this. So I'm really interested to see what's going to happen here. Okay, so here's the scenario. You are all now, you have to imagine now that you are all participants in my workshop. We are gathered on the first floor of this building here in the foreground at the University of Colorado Denver campus in downtown Denver. And one wall of that of the conference room on that first floor, it's all glass. There's floor to ceiling windows in that conference room. So perhaps that could be dangerous in a tornado. We'll see. But we're gathering for this workshop, and after some preliminary information is exchanged, basically you will receive on your mobile device this message. Again, it's the wireless emergency alert 360 tornado message, and it says, National Weather Service, tornado warning in this area until 4 p.m. MDT. Take shelter now in a basement in an interior room on the lowest floor of a sturdy building. If you're outdoors, in a mobile home, or in a vehicle, move to the closest substantial shelter. Destructive tornadoes have hit Denver before. Probability of tornado strike at your current location, blue dot. And you can see here, the blue dot shows your location at the downtown Denver campus. And you can see from the legend that you are currently in the 0 to 20% probability for tornado strike. So I'd like a couple of participants here today to unmute their microphones and tell us, what action would you take or not take as a result of receiving this warning message on your cell phone? Thank you.
Hello?
Hello. Hi, Dimi-san.
Yes, this is, Dimitris. Thank you. I think that based on that, imagining myself in this scenario, I think the first thing I would do is try to check where I would go if the situation changes. I would probably not, given the 0 to 20% chance of being in the trajectory of being impacted by the tornado, I would probably seek to confirm what my next steps would do, rather than just go to the, for example, basement of the building and wait there for updates.
Okay, thank you very much, Dimi-san. I appreciate your response. So in Dimi-san's case, he would look around for perhaps where to go if the situation gets worse. But at this point, he would not take immediate protective action. Can we hear from someone else about what they may do or not do in this situation?
Hello, Professor. So maybe in my case, I thought you already mentioned that we are in the conference house with a window around us, right? So I think I will immediately leave the conference room and go to maybe some bathroom or something.
Okay.
Yeah,
please tell us your name.
My name is Zhang Huan, but you can call me Alex.
Okay. Well, thank you so much for your response. So here we have a more risk-averse participant, so more likely to take immediate protective action given that one wall of our conference room is actually floor-to-ceiling glass windows. Thank you very much for your response. How about one more person?
Thank you.
Anna Maria Sensei, is your hand raised?
Yes, since nobody's volunteering. So I would also probably do as Dimi suggested. But one thing I don't see here is anything about the time. I mean, is that 4 p.m.? Is that for the people that are closer, or is it for the people in Denver? I mean, because storms are moving, so maybe this cone should also be moving. Anyway, I would probably do similar as Dimi and hope to get more information.
I appreciate that response, Anna Maria Sensei. And let's imagine now, for the purposes of this scenario, that in fact 4 p.m. is the time that the tornado will apparently, the warning will be in this area. And currently, according to my phone, it is 3:40. So apparently the warning is in this area until 4 p.m. So for the next 20 minutes. Would that change your interpretation or response to this message?
It's not clear to me what that means. If it's 4 p.m., it's going to be 4 p.m. 20%? That means, will it stay 20% until 4 p.m.? That's the question. That's why I think, like Dimi, I would look for more information.
All right. Well, what you're seeing here, I appreciate that response, Anna Maria Sensei. This is wonderful. And what you're seeing here is exactly the kinds of exchanges we hope to have in the workshop, where people are trying to make sense of this message. They're asking questions, things that are unclear are coming up, and people are responding to the comments of other people in the workshop. And this social meaning-making process is occurring. So we know that Anna Maria Sensei and Dimi-san are going to be looking around for where to go next. So now let's imagine that a few minutes have now passed and we've had our earlier discussion, and another mobile alert message appears on your cell phone, and it looks like this. It's the same message as before, and the time is still 4 o'clock, but the warning has been updated with a new fee visual. And now you find that you are in the 40 to 60% probability of a tornado strike. So let's go back to Dimi-san and ask him how his response might change now that he's received this updated message. And I should say, in our workshop, or actually the NWS officials, they've told us that usually they would plan to send updated fee visuals and messages like this every 10 minutes during an acute emergency for tornado strike. So you can anticipate receiving these messages every 10 minutes. But Dimi, let's go back to you.
Okay, yes, thank you. I actually appreciate very much Kru Sensei's point about the time. That clarified a little bit the situation in my head as well. I perhaps mistakenly imagined initially, and I think it's important for you to hear that based on this fee visual, I was under the impression that I still had a lot of time, or at least I had plenty of time in order to first assess the situation and then decide on whether I want to take protective action or not. Time I think is relevant. Of course, in this scenario, the only difference would be what time was the actual time that we received the warning, and then compare that with the time in the message, that the time predicted, the estimated time of arrival, I guess. So I think this is an issue to consider. Based on the current situation, I would probably take protective action now and keep again checking for further updates. Okay. So at this point, I would probably move to perhaps a more protected place within the building.
Okay, understood. Thank you, Dimi-san. And this is perfect because this is exactly the kind of information that we want to elicit from our workshop participants. For example, is the 4 p.m. warning time, do people interpret that as being encapsulated on around every fee swath, every fee plume, or within the particular plume that they find themselves in? This is, I think, a question that the Weather Service and NOAA have not yet considered. And it's very important in the context of mobile alerting. So this is exactly the kind of information we want to discover. Let's turn to our friend Alice and now ask, how would your response change, if at all, from before?
Because I'm a very careful person, so maybe you already see my answers that if we are in the 0 to 20%, we are in danger of the tornado, I will immediately rush into the bathroom or something. I think that may be very safe because I'm afraid that the tornado will come very soon, maybe before the 4 p.m. So yeah, so my first choice is still to go to some places. I think that will be very safe for me.
Excellent. So interestingly enough, we can see emergent norm theory in operation here. The new information is creating a new norm. And now we see Dimi-san and Alice-san leaving the room. And let's ask if Anna Maria Sensei will follow them. So Anna Maria Sensei, what is your response to the second warning message? Oh, you're muted, Anna Maria Sensei.
Okay, I would take shelter as well. One thing that occurs to me, with hurricane forecast or typhoon forecast, you always have the center. You have a forecast of the center moving and the time of where that center will be. It gives you an idea of how much time you actually have, right? And so that, I think, learning maybe from hurricane warning could also be very useful for, of course, maybe the time lag is much longer. So, but anyway, I would take protective action, but I still have doubt on exactly what you said at the beginning. What time is it now? So how much time do I have left? And is this warning only for this swath or, yeah.
Absolutely.
Thank you.
I appreciate those points, Anna Maria Sensei. And certainly the centroid effect, what you've seen in hurricane and tornado warnings like this, where people perceive the intensity of the storm to be increasing at the sort of center of the visual. That's going to be in play here as well. So your point is well taken. Let's see now, before I move on, whether there's anyone else who'd like to make a comment about what they may do or not do in this situation, especially if you have a different reaction. And I think I see Song-san raising his hand. So please go ahead.
Thank you very much for your presentation. And I have a question about the warning. And if I take a mobile phone, I can receive the message of the picture, and I can know the location of the legend, or if I location in the center of the tornado, and
That's right.
I can see the picture, or just that probability.
So in the messages that we're testing, we're imagining.
Okay.
Yeah. Currently, this type of message is not available in the United States. The FCC prohibits the inclusion of visuals in the message. So what you might see, what you do see, is something similar to the text.
Okay, I see.
The visual. But in this situation, because the Weather Service intends to share these visuals in the future, and the FCC is currently debating and having discussions about whether and how to include visual content in these messages, we're testing it like this.
Yeah, thank you. And because I think if I can get the picture, and I will go to the closest boundary of the influenced area, I think. Thank you.
Okay. Thank you, Song-san.
Thank you.
Anyone else would like to make a comment or ask a question or tell us their response before we move on?
Hamilton Sensei, yes. This is Nakano speaking. Do you hear me?
Yes, thank you, Nakano Sensei.
Yes. Yeah, actually, if I were there and if I received this kind of information, since I am not so familiar with the tornado phenomenon, and maybe I'm visiting just as a participant on the workshop from outside of the United States or Colorado. So maybe what I will do is to check the first, of course, the moving speed, or how long does it take to reach to my positions or my place. But secondly, what I'd like to know more is maybe the intensity. So I don't know if this tornado is quite dangerous or not, or how it affects people, since I'm not so familiar with this kind of phenomenon. So yeah, I will check if I can get the information of intensity. And of course, if I are in the area of orange, like 40 to 60% of the possibility or probability, I will take a protective actions, maybe going to the restroom where there's a lot of walls or some other safe places.
Okay, thank you, Nakano Sensei. So absolutely a kind of textbook description of milling behavior. You would seek additional and confirming information from the physical or social environment, maybe checking your phone for what other information you could find, but also taking protective action as part of the emergent norm that is occurring with the other group members who are also headed to the restroom in the interior part of the building. So I appreciate your response. Let's then now hear from, is it Taha-san? And then we'll move on. Taha.
Yeah, hi. Can you hear me?
Yes.
Yeah, hi. So as somebody who has never been in any natural disaster ever, I would be very confused as to what to do. So I would like look around for other people and like go to them immediately and try to like assess what they do and then just follow the crowd. I think that is what I would do.
Okay, well, excellent. I mean, and I appreciate the response because we anticipate that workshop participants will have this response. And so we want to see how this emergent norm of the group now moving toward the interior of the building, how this affects others. And so this is exactly the kind of thing that we anticipate seeing. So I appreciate your comment.
Thank you.
Let's move on to make sure we have time for question and answer at the end. Now, again, I was going to show you our final mock message here, putting you in the 80 to 100% range of tornado impact. But since everybody has already gone to the interior of the building, they're going to remain safe and nobody will be hurt in this scenario. but you can get a sense of what we're trying to do in the workshop. We're going to have 6 groups, 6 workshop groups. We're going to show them different combinations of messages, some at 10% probability, some at 50, and some at 90, different orders of showing them these messages, and do exactly what we've done with you, which is ask them to comment, but a little more systematically, and we'll have priming questions and follow-up questions. But understanding the sense-making process to elicit from them issues about these messages and how they might be used and interpreted. We're going to use this think out loud method for uncovering participants' internal and cognitive processes. And it's been used to study WIA messages in the past. I've used it myself. And it's also been used to study tornado messages by a colleague on the START research team, Jeanette Sutton, Dr. Jeanette Sutton. She's recently used this think out loud approach in a new study of tornado messages. So we'll read each message sentence by sentence, and we'll ask participants, tell me what you think when you read those words. And participants will describe their thoughts and feelings as they reread, puzzle over, question these mock messages, as you've seen them do a little bit today in this presentation. Of course, we want to ask participants what actions they would take both before the milling activity occurs and after. So before we even have the discussion, we'll distribute a questionnaire, and we're going to ask people, what action would you take and why? We'll record that. Then we'll do our discussion around this sort of emergent norm that occurs, and then we'll distribute a second questionnaire, and we'll see whether people's responses have changed at all or not, compared to the first questionnaire. And any answer is fine. If the emergent norm did not change people's intended protective action, that's interesting to know. We don't really have much research on this either way. Now, if the emergent norm significantly changed people's behavior, that's also interesting to know, because it shows that milling really does influence people's interpretation and responses to these messages, and it must be better accounted for in the kinds of studies that are occurring around fee visuals and warning content. Okay, so again, to advance this CCWI approach in the United States, we're going to have a final workshop or a meeting basically with 2 workshop participants. We'll identify those folks later. We'll invite them to join with the Weather Service officials and Denver emergency management officials, and we'll have a discussion about what we learned as a result of this process and how it might be useful to stakeholders going forward. So this more or less comes to the end of my presentation, but I'll leave you with a couple of questions, and I'm happy to take questions now. But my questions for this group would be, what should be the #1 goal of the National Weather Service with these fee visuals? Should it be more accurate risk perception, which we know from experimental findings does improve with these fee visuals? People make better assessments of the personal risk, and you saw our participants today make pretty good assessments. But protective action compliance, maybe that should be the goal. That's harder to achieve. But what should be the goal of NWS with these messages, do you think? Second, how can the study of the social meaning making process contribute to fee development and use? What do we learn by asking people in a group what they would think and do? And how does those group norms and group emergent norms, how do those factors help us understand this process for fee development? And finally, a more ethical and engaged question: what responsibility do officials have for creating and using fee messages that maximize the number of people who take appropriate protective action for tornadoes? So we have these technologies available, but as I mentioned, right now, the inclusion of the visual is not permitted by regulation in the United States. My hunch is that this will change within the next 3, 4, 5 years, and that you will see these images included. And the question then is, what responsibility do officials have for including information like this? And also, what responsibility do we as researchers have for helping officials use this technology in effective ways? Here are the references for my presentation, and now I'm happy to use the next 30 minutes or so left in the time here to answer any questions you have. Thank you very much.